Welcome, guys, to part 3. We're gonna continue where we left off. So let's see what we are left with. So, in terms of the voting grid, we still have to read from the files, right? So, I'm gonna have to import the fstream library. Fstream, the F stands for file, and then the stream just stands for stream. So this is, in essence, is basically for file streams or for handling a stream of to for working with the stream of files or whatever you want to view, however you want to view it. But that's basically what fstream is for. It's for file handling. We're working with the stream files. So let's go to our implementation file and look at the functions that we need to implement. So let's start from load to text. So it's going to take in a file name that we're going to load from text, and then the file name that we're going to save to in binary. So with the text file, it's a bit straightforward compared to the binary file. So I want to, let me see. You can get the, let me see. I'm looking for that function. Okay, before we continue, we need to add alignment padding. So alignment padding is we use the hash pragma preprocessor directive. So the hash pragma preprocessor directive, its main goal is just to communicate with the compiler and tell it what to do with the data. And in this file handling part, the way we want to use the hash pragma, or the information that we want to send to the compiler, is that for it to sort of like pack the data in terms of bytes, and we're going to pack it in terms of 1 byte, so that the alignment padding, the alignment is going to be set to 1. So 1 meaning 1 byte. So in a way, we can view it like this. So it's to make things easier. So it's like I'm gonna have 1 byte here, and then the next. So therefore, I know that the next coming bytes, the next 1 byte is gonna be so the next coming byte is gonna be another record structure. So that's how I'll know when the next information or the next record structure is going to come, because they're all separated by 1 byte. And if you remember what byte is, 1 byte is equivalent to 8 bits. What are bits? Bits is basically an abbreviation for binary digits. So basically, when you say 8 bits, we are saying there's 8 binary digits. And those 8 binary digits, it can be any digit. Can be like this, 1 0 1 0 1, something like this, right? So there's 4 6 8. So there's 8 binary digits, which are equivalent to 1 byte. So in a way, it's going to be like this. So since we now know what 8 bits are, what 1 byte is, it's equivalent to 8 binary digits. So it's going to be something like this. So we're going to have that's the first byte, then we're going to have the next byte, then we have the next byte, and so on. So now the computer will be able to tell where to start and where to begin, where to stop. So it's gonna start here and then it stops there. Then I've read the information for the first voting district in this case, yeah. Because if we check the The record structure is for voting. Okay, I think I'm gonna be reading for information about the voting district. Let me just double check. The file contains format UAP, population, APU support. Exactly, yeah. We're going to be reading information about the voting district. So therefore, this byte will be representing each voting district. So maybe this is going to be voting district 1, voting district 2, voting district 3, and so on. So they'll be separated by 1 byte each. So each voting district will be separated by 1 byte. So by 8 binary digits. You might ask, what's the whole point of doing this? It's trying to make sure we have very fast access speeds. So we know, we at least know where to start and where to stop, because we've packed everything in terms of 1 byte, or everything is separated by 1 byte. So everything is separated by 8 binary digits. So that's the whole point of packing this data or aligning this data. So let's see what record structure. So it's the voting district one that we're supposed to have. That's supposed to have alignment padding. The voting district structure as per given table will have with alignment padding. It should be having alignment padding. So I'm gonna use the hash pragma, and then I'm gonna use the pack command, and then pack it. So I'm gonna push it. You can do it in 2 ways. You can say hash pragma push like this, and then you say hash pragma pack, and then you specify the size. How many bytes do you want to save this thing? You can save it in terms of 4 bytes each or 2 bytes each, but let's just use 1 byte. You can use anything, any structure that you want to use. So I'm going to pack this data, right? So when I'm packing this data, I'm going to push it. I'm going to push it in terms of 1 bytes each. So pushing it is just basically adding it to the file. I'm going to push it in terms of 1 byte each. And you can combine these 2 lines into 1 line like this. You just say comma and you put the 1 there. Then this one disappears. You can use it like this. And then once you're done, don't forget to restore to restore the alignment padding. So you've packed this thing, so you need to restore it back so that we can reserve another. Next time when we want to reserve another reserve memory for another voting district, we can go back to the top again and then create 1 bytes and then store that information for 1 byte each, and then you pop again. So it's always going to be like that. So if you check here in the slides, for the sake of effective reading and writing in C++, will by default ensure that certain data members have a particular byte alignment. So they're aligned in terms of bytes. So you can, that is, it starts on a memory address that is an exact multiple of a number of bytes. Exactly. So we start by storing the data in terms of a specific size or number of bytes, and then the next data is going to have another number of bytes. So depending on the data type of that member, the compilation settings, and whether the operating system is 16, 32, or 64-bit. So depending on that data, on the data type and the compilation settings and the operating system, whether it's 16 or 32-bit or 64-bit. This is achieved by automatically adding a certain number of padding. So that is basically allocated memory which will be ignored. So this behavior can be controlled by the mechanism to do this, to do this is not standard. So you can save the alignment settings. So when you say Pragma push, you're saving the alignment settings. And then you can set the alignment now in the next line, or you can combine them both. And then you undo those alignment settings. So once you've aligned and you've saved the data, don't forget to undo those changes so that when we need to save new data again, we allocate 1 byte and then save that information. Yeah, I think that's all you have to do now. That's all we have to do now. Then we've done alignment padding. Now, here just undo changes. And then we've done alignment padding. So now we can work with our record structure. We know that each data or each record is stored as 1 byte. So we have this, we need to read from the file. So in order for me to read from the file, right, I'm loading from the file. So since I'm reading, remember that I'm reading. So I'm getting something. So remember you've been doing input stream you've been using input stream objects, output stream objects. So you've been working with the IO stream. Remember that when we're reading information, we basically what? Getting input. And then we used the cin input stream object, right? So it's going to be the same thing. We're going to be getting input, but now the input is not coming from the user or from the terminal. It's coming from the file. So how do we do that? So first things first, I need to create the stream object. But what type of a stream object? A file stream object. But not just any file stream object. I need to create an input file stream object because I'm dealing with input. I'm reading from the file. How do you do that? You say if or if stream like this, which means input file stream. So I'm working with the I'm working with the file stream in terms of getting input. And then I can just call it file input because I'm getting input. And then there's two ways you can go about doing it. You can just declare it like this. Okay, before we continue, let's not forget to close the file. So file input dot close because you have to close the file. Remember what we in essence what we're doing, we're doing this. Yeah, saying new, and then let's say there's a file that's already existing, some file, right? So what I'm doing here, I'm writing it programmatically. So I'm basically writing it in terms of code. So what am I writing in terms of code? I'm saying go open this file. Which file? I'm gonna pass the file. So it's going to open the file like this. So how do we open it? The file. How do we open the file? We can open it via the constructor of the file input stream. And then as you can see, there's the documentation. It takes the path or the white character, what, everything is of type string, as you can see. All of this are of type string. Char pointer, one-dimensional array of characters. What is that? It's a string. What is a white character? And there's a pointer to it. It's a string. Then you can also actually take in a string by reference. So I need to pass in a string. It's either the path or the path of the file name, whatever, however I want to structure it. So the file is usually going to be stored inside like the data folder. Yeah, I think there's gonna be a data folder. And then / followed by the name of the file. The question is, what is the name of the file? Mm, yeah, that's the problem now. we don't have the additional oh, okay, there it is. But we don't have the file. That's where the issue is, but we're just gonna write the code. So there it is. There's the file that I want to read. So it's gonna be called input.txt. But if it's not saved inside a folder, you can just omit the data, what, and just write the name of the file. You can also do that. I'm gonna do it in that way in my case. So what this means, it means that when I go to my project, it's right there. It's not inside a folder. It's right there with my header files and my CPP files. That's what that means. But if I had written it like this, it means that I need to go to my project and then look for the folder named data. Within that data folder, open a file called input.txt. So that's what I'm doing. I'm opening the file here via the constructor. Or if you know that you're going to forget the syntax, I suggest you do it the normal way, the other way. So file input dot open. What's the name of the file that I'm opening? It's input.txt. You can do that. So I'm actually, you see what's going to happen here? It's literally going to open the file. So it's literally going to go to a file named input.txt. So it's going to go here. Where's okay, it's not here. So let me scroll down. And then where's CLion project? There's the project, right? So it's going to go here, right? And then it's going to look for a file named, let me just create it, input. So it's going to go here and what was the code that I wrote? I said open. So it's going to go here and then double click. It's going to do that. It's going to double click and open the file. But I'm writing it programmatically. So I'm writing it in terms of code. I'm not literally going there. I'm telling it to go and do that for me. That's the power of programming. So the computer is useless without your programming skills, without a programmer to tell it what to do. But it becomes very useful when you have a programmer who tells it what to do. As you can see, I told it to open a file, which is something very powerful. I didn't have to open the file myself. So it's going to come here and then open this input.txt, and then I can write to it, I can read from it. In our case, we want to read from it. So you can also even pass what we call extra information, which is like the mode. So you want to do what with the file? So you want to open the file to read from it or to append to it. Append means just to add more text to whatever text is already there. So we can do that, or we can say we want to open this file in binary mode. We can do all of that. So I can be explicit. By default, that's what it does. It opens the file in read mode because I've created an if stream object or input file stream object. But I can also be explicit and say iOS, what do I want? I want to, there you go. You have append at the end. That's what 8 means. It means at the end. Binary means you are reading it in binary. Yes, you are reading it in terms of input. Input means that you are reading from the file. Out means you are writing to the file. Truncate means that remove whatever was there when you're either reading or writing to the file. You can do that. But by default, it does that. It truncates. If you are writing to the file, by default, it truncates. It deletes whatever is there. So if you don't want to delete, you have to you have to explicitly say that you want to append to it or add text to it. So I'm going to use the in mode to specify that I'm reading I'm reading from the file in terms of input. I'm giving it reading privileges. So it has the privilege to what? Read. So it should only read. So it should only open and read whatever's there. And in order for you to read whatever's there, I would have to know beforehand what's the structure. So we were told what the structure is. And you can also combine, you can also combine commands, the modes, by piping, by putting that symbol there. Then you also say, okay, I want to read this file, but I want to read it in what? Binary. You can do that. That's what you're going to do in the other function. So you can do that. There we go. So I've given it the privilege to read. But by default, the privilege is set. I was just showing for demonstration that, yeah, I'm using iOS in. So I feel like this mode, these modes, you should use them if you did it like this. You just say fstream and then f in something like this. You just created a file stream object. So it's neither an object for reading nor an object for writing. I would say it does both. Yeah, I think it does both. So since we have an object that does both, that's a problem. We only want to what? Load from the file. So that's where the modes come into place. That's where you explicitly state what you want to do with the object. How do you want to use the object? So I'm going to do that. And then I'm going to check to make sure that the file is open. So how do I check? So file input, I can do it like this and say while is not file. So while is not file means that while it didn't open the file. So the file is empty. So if it is empty, then yeah, we're gonna have a problem. Or you can say while is opened, dot is open. Is open means that the file is open. And then you say not. So while the file is not opened, what does that mean? That means that we couldn't find the file. So you can output an error and say the file was not found. So you can call the standard error stream and say file not found. And you can also be explicit and state the name of the file. I think you can get the name of the file. Dot, let me check. Let's check the name, but there should be a function to do this. Fixed, good, hex, internal, scientific, that's for dealing with science stuff. Come on, what is it called? Don't tell me it doesn't have. Yeah, I don't see it. I don't see the function for I don't see the function for getting the name, but yeah, if the function was there, you could just say file input dot get name, and then you output the name of the file that we couldn't open. But since we're already taking in a file name there, I'm not going to be explicit. Yeah, I've made a mistake here. I'm not supposed to be explicit. I just need to pass in that file name. At least I have access to the file name here. So I can just say cr this file name. And then I could say could not be found. Then put a new line character. And then since I'm going to have more than one line of code, I'm going to put the curly braces there. And then I'm going to exit. And then I'm going to call it the error file. I'm going to add it to my enum. So that means this one's going to start at -2 now. Error in file. So there was an error in the file. That's the constant I'm going to use. Error in file. Then we are done. We've read from the file. We've made sure that the file does exist. If it doesn't exist, the program stops, it exits. And before it exits, it notifies the user what was the issue, because there's no point in a program exiting without you knowing what was the issue or what was wrong. So it needs to notify you. So we've opened the file. So now we can add to the file. How do we add? If you remember, you can send information to the output stream object, but this is, we're adding to the console. That's what the C stands for. It stands for console, or the terminal. That's another term for it. Terminal. It stands for that. So we were outputting, you see, out stands for output. So we're outputting to the console or terminal. So now we're no longer doing that. We are outputting to the file by referencing this object. So now it's going to be like this, file input. It's going to be like that. And then we send text to this file. Oh, okay. Yeah, my bad. We supposed to be reading. But yeah, this is how you would send text to a file. It works the same way with cout. It's exactly the same structure with as cout and the string stream. Streams, that's basically how you work with streams. And then if you want to get input, you'd use it the same way as cin. So we're getting input from the console or terminal, and in stands for input. So get input from the console or terminal. That's what that meant. But now we're dealing with files. So I'm gonna say file input, get the input from that file, and then store it inside some variable like this. But I'm not going to use file name. I'm just using file name so that you can see for demonstration. So you get input from here and you store it inside a variable. So that's what we're going to do. So let's see the structure of the file. So EOL, it means end of the line, end of line. So we're going to start, the first thing that we're going to read that's not going to be repeated is the rows and columns. So the first two values are not repeated. So I'm going to get the rows and the columns. So okay, so this file contains information, but instead of getting the information from the user or command line as command line arguments, whatever, we're getting the information from the file. So these are the actual rows and columns of my two-dimensional array. Because remember, this is the information about the each voting district. As you can see, each district. So I need to do that. So what I'm going to do is I'm going to read the first two values, which is the rows and columns. So I'm going to store them inside underscore rows. And I can just do this in the next line and get the columns. Or you can just combine. In C++, it has this ability to combine. You can just combine like this and say underscore columns, like that. So what it does is every information that you're getting is separated by space. So it's going to look for the next first rows, the first value that's there, that's an integer. It's going to check the type of the integer. It's unsigned. So it's going to take, obviously it's going to be a positive value. We can have negative rows and on no negative columns. So it's going to take those values and put them here into the first variable. And then the other one's going to be put inside to the second variable. So what this means, this one line of code, what this means, it's saying, take the first integer that you see, followed by the next integer that you get, then put them inside these variables. So if my file was like this, it means that 192 would go inside rows, and then 283 would go inside columns, because the first integer that was there is 192, so it's going to go here. Then this, it means that I'm also getting input, but the input that I'm getting is the next integer, which is the next available integer after the space. The moment you don't put the space like this, it's going to read it as one number. So that's why in our files we put spaces there so that you can distinguish. You'd be like, oh, so this is the next first available integer. It stops at 2 because there's no other integer after 2. There's just a space. Then the next integer starts at 2. Oh, and then it stops at 3 since there's no other available integer after 3. So we've read the rows and columns. So now we know how many thingy districts we going to need. So now the question is, how are we going to read the districts? So the way we're going to read the districts is, let's see. Oh, so the district ID is going to be based on the row and the column. Remember that we got the rows and the columns. So we're just going to keep track of the current row and column of that district. The undecided value must be calculated based on the UAP and what values. Remember, support values must be a total of 100%. So yeah, we need to do that. So let's do that. So I'm going to need my rows and columns since I now know how many values I have or how many districts I have. So unsigned int r is equals to 0. R is less than underscore rows, R plus plus. Okay, and then I'm gonna have for int unsigned int C. Now we're going through all of the columns because for each row we have the same number of columns. So now I'm going to keep reading based on this information because if you check the file, it's going to have a collection of this UAP support, APU support, and population. Then on a new line, it's going to have other information. So it's going to be like this. So let me show you how it's going to be structured. Just that I don't have the file here, but I know exactly how it's going to be structured. Remember, EOL means end of the line. So that means I must start on a new line. So it's going to be like this. You can see it, right? It's going to be like this. So I'm going to have rows and columns. So I already know how many rows and columns because they gave me at the beginning. So the way the way this file was structured is like this. They give you rows and columns here, and then that's the end of the line. You start on a new line. So what's going to be the rows and columns? It depends. It could be 25, 23 here, and 25. What those two values mean, it means the amount of entries we're going to have here. These are the amount of things that we're going to read. So those two values were indeed important. Don't save. I don't want to be reading such data. But yeah, let me just do it like this. Let me just create dummy data. As a matter of fact, let me do that. Let's say we're going to have 25 by 25. And then APU support. So let's check. I'm going to have APU support population. These values. The support must be between 100 to 0 and 100. So what I'm going to do is I'm going to generate based on what I'm given here, and the population must be greater than 0. So I'm just going to come up with random values. So I'm just going to say 66, 75, population to 2,900, 55, what, any value is fine, because at this point we don't have dummy data. And then 9, okay, can't be greater than 100, so I'm gonna have 95. 100, 55, something like this, and 45. 88, 19, then 76, 23, 2, 3, 100. Let me just say 99, 47. Yeah, this is what I'm going to write into the file. Just dummy data. Oh, I can do this because now this thing is gonna be, it's gonna be very tricky because now I don't want to come up with values that I know, and I want to have a lot of values. So, and I want to have 25 by 25, right? So what I'm going to do is I'm going to generate random values for this. Like I'm literally going to generate random values and then add it to my file, right? So let's do that. So I'm going to create an extra, what is this? Function. So let's do that. I'm going to need an extra function for this. An extra function to write to the file. And I'm going to make it public because the issue is that I don't have values. I don't have the file. I need to generate it myself. So I'm just going to say generate values. That's what I'm going to call it. And it takes in some file name. Yeah, you don't have to implement this function. I'm just implementing it so that at least when we run our program, it displays something. And I'm creating it so that it makes things simple for me. I'm going to use random rows and wait. It becomes it becomes very problematic now. Because if I generate the values, I need to know the rows and columns, of which the rows and column I'm going to have to read from the file. So I think what I would suggest is we actually generate the values first. So I need to also generate the rows and columns. Yeah, I'm just going to generate the rows and columns. So I don't want it to be too big. I'm just going to make it 25 by 25. Those are the rows and columns that I'm going to use. So I'm going to create an OFStream object because I want to output the file. And I'm going to call it output. And we're going to use the second syntax. Which file are we outputting to? It's input.txt. And then I need to close the file once I'm done. Because there's no way you'd do this. There's no way you'd open the file, you'd write something, and then you just leave it like this and not close it. You'd have to close it. So after it was opened, it needs to what? Close. I don't want to change it. I want to leave it empty, so I'm gonna click cancel. So what this one line of code does, it creates the output file stream object, and it also calls the open function simultaneously. So it takes in the file name that it has to open. So I'm gonna use that second structure. So that's second syntax so that you can know the two approaches of doing it. So now I need to write to the file, right? It's very simple. The way I would use cout, but we're sending text or data to the console. Now I'm sending it to my file. How do I reference the file? Through this object called output. So output, what do I want to output? Output 25 and put a space and then output 25 again. So because I want it to be, the first two values I needed to be 25 by 25. I want it to be the rows and columns. And then I put an end of line character. That's what EOL means. It stands for this new line character. So what I'm going to do right now, I hope it's going to allow me. I want to just quickly demonstrate how we're gonna do this. I wanna actually call that function to, yeah, it's a voting grid, obj grid. I wanted to, okay, we're not gonna, so we're always gonna use the default constructor because at the end of the day, the rows are not known. We have to get the rows. So I'm just going to say obj grid dot generate values for what file, what's the file name, input dot txt. Well, I also made a mistake. We need to fix it. I hard coded the file name. I need to just pass that name that I'm getting via the construct. And then where's my main? There's my main. So if this runs, at least we know in our file we're gonna have okay, expected class name. Let's go there. Okay, the forward declaration thing, class voting analyzer, and then the other one, well, it's there. Error, use of an incomplete class voting analyzer, blah, blah, blah. It seems like this thing won't allow me to continue without having the code inside the CPP files. So let's do that. Let's implement the CPP files. So what I'm going to do is I'm going to remove the main, remove voting grid, remove this, and then just open these ones, the different types of analyzers. And then battleground analyzer. So there we go. We have the different analyzers because I feel like that's why it's complaining. I didn't implement this function. It's just there. It's not implemented. Or you didn't at least make an attempt to implement it. So it's obviously gonna complain. It's gonna moan at me. There's no need for you to use virtual when you're implementing because it already knows it's virtual. Then we'll have this. Come on. There we go. That's done. So it assumes if you've implemented the function. Wait. I'm using the, I think I used the wrong name for that one. What file name was it? It was potential fraud analyzer. Okay, that's fine. Okay, yeah, that's fine. That's fine. I don't know why I was worried about that. That's fine. And oh, yeah, the functions are the same, so I can literally use one header file. So that means I can just delete all the other header files and just reuse this one header file so that I don't have a lot of files looking at me like that. And you see, it even complains, at least this IDE complains, code blocks won't complain about the virtual. As you can see, you need to drop the virtual once you're implementing. You can also even drop it here when you're declaring it inside your header file. You don't have to necessarily include it. The virtual is just there to remind you that, oh, okay, you have a virtual function in your base class. So you are now implementing it in your child class so that you remember that this is an abstract function. And then I'm only going to open main, then we're going to try again. Well, this thing is issues now. Yeah, it is a forward declaration. Why is it complaining? Error string does not name a type. Well, I know, I'm just gonna do this. So now I need to do that again and again for, okay, I don't have to worry about doing like this. I'm just going to, but wait, inside of my voting analyzer.h, I did say using string. Why is it? That's the thing about C++. And it's gonna start making issues again if I redefine things, but for the sake of handling these errors, I'm gonna do that. Potential fraud using standard, using the string from the standard namespace, and then using string from the standard namespace. What other errors do we have now? Complaining about voting grid. Does not name a type. Okay, I need to do forward declarations for them. So let's do that. So class battleground analyzer, class potential fraud analyzer, class predicted outcome analyzer. So we have forward declarations on that. Error voting grid does not name a type. Okay, so some don't have the forward declaration for voting analyzer. Where's the does not name a type again? But there it is though. Oh, voting grid. Okay, so it's complaining about voting grid. Voting analyzer is not a problem. But wait, I did include the voting grid inside the voting analyzer. If you check, there's the voting grid. There's the forward declaration for the voting grid. So I don't know why it is doing that, because now it's gonna, I'm trying to avoid this thing of secular dependencies, like re-including things over and over. It's unnecessary. If it's already included in the header file, it should be working. So let me see. Should I just include the header file or just do a forward declaration? I think the header file will do. Let me just include the header file. Voting grid again. Incomplete. Yeah, it is incomplete. I know, but it should allow me to inherit. They shouldn't be complaining. In member function where dot analyze const, no return statement. Yeah, this thing requires a lot. Don't want to implement that yet. Let's just do the voting grid for now. We'll get to the child classes. So voting grid.cpp. So I did output to this file the first two column, the rows and columns, the size. Now I need to create a helper function for generating random values. And I'm working with doubles. It's fine, I'll just cast. So int generate random. Oh, I'll just call it random. Let me just call it random. Let me keep it nice and short. So I'm gonna have lower for the lower bound and then upper for the upper bound. And then I'm gonna return. Yeah, I need to use the ctime library hash include ctime library, and then I'm going to say return rand modded by the range. What is the range? It's the upper bound minus the lower bound plus 1, and then plus the lower bound that starts at that lower bound. And then that's it. I'm done. I have my random function. And then now I need to find the file to generate values. There it is. So now we have the rows and columns. We've saved them there. And then now I need to iterate for every single row and column so that I can generate the number of the values for each row and column. Unsigned int r is equals to 0, and then r is less than 25, r plus plus. Then for unsigned int c is equals to 0, c is less than 25, because I know the values that are stored in the file. So now I'm going to output to the file the APU, right? If you check the syntax, we start by the UAP, no, not APU, UAP support, but it doesn't really matter because at the end of the day, it's just a value between 0 and 100. So I'm going to call my random function to generate a value between a 0 and 100. And then this value, I'm going to cast it to a double because it should be a double. There we go. And then followed by a space, then followed by another value, another the APU value, which is also a double, and should make it random between 0 and 100, and then followed by space, and then followed by the population. The population is an integer. If I'm not mistaken, it's an integer because you can't have 1.5 people, so it's an unsigned integer. So it can be from 0 to some maximum, which is like this 100,000. So we're gonna use that maximum value. So double a random value between, and we can also reuse mean value if you want. So I'm gonna use that mean value until max value. So those are the random values that will be generated. And don't forget to add a new line character so that each line has its own unique values. Because I'm trying to achieve this, I'm gonna generate a random value between 0 and 100, let's say 39, 38.0, and then a space, there's the space here, and then another random value, and then convert it to a double between 0 and 100, let's say 88.8. And then the population, random value between 0 and 100,000. So let's say 9,999. And then it needs to add a new line character, EOL, that's what it means. So in line character, so it needs to start on a new line. So you see, we end up having the structure that we want, which is the structure that we were supposed to be given the file. Just that we don't have the file, so I need to generate the information for myself. And I need to work with random values. So now I know for a fact that I'm gonna have values in my file. If generate function, I don't have to worry about that now. So now I can read the file because I know the file is gonna have values. So I'm gonna read the first two values, which is these two, the row and the column. I've read those two values, and then now I go through each row and column because this is how they were stored, row and column, using the rows that I've received from the user, from the file. And then now I store, we start with the, what's the, what? UAP and APU. So I'm gonna start with the UAP. So let's do that. So file input, then, or you can use you can use this function. There's the get line function. So you can say get line like this. get a line. Which line are you getting from? I'm getting it from file input. And then where do you store that line? I'm gonna store it maybe inside the string stream, SS, or a string. You can use, I think you usually use a string. Yeah, I think you use a string. Yeah, and then you store that line that you get from this file into a string. So while get line, so it's gonna using a while loop and say while there's a line to get that line from this file and then store it inside this variable or this string. Then you can work with that string and you can work with that string and then take the individual values one by one. You can do that, but I don't have to use that because I did have the rows and columns. I need to show a certain level of understanding that I do understand what's going on. You've given me the number of rows and columns, so I'm going to use them to my own advantage. So, so let's get the values. So the first thing that we're going to get is the UAP. So how do we get that? So remember that we're gonna need, let me see. We are reading from the file. Then after reading from the file, we have the rows and columns, right? But then now, where do we store the rows and columns? That's the question. Do we, wait. I see what we need to do now. So what we need to do now, we basically need to allocate memory for, we need to allocate memory again. Remember that we're gonna instantiate this object, right? It's gonna have some default rows and default columns. And then we're gonna use that object, but those are not the actual rows and columns. So I need to allocate memory for it again after getting the size from the user. So I don't have to implement or do a lot of things because I have a helper function. I'm just gonna call the constructor, which takes in these rows and these columns. So now it's gonna resize it and giving it the right size. And then for the district, it's just the default district. And then now I can work with the array because the array now is of the right size, it's of the same size as the size that I've received from the file. So now I can just say voting at that specific row and column, take and put it into UAP support because that's the first value. And then, no, it's in the wrong direction. I'm getting input. And then we also going to get, okay, let me just, it's gonna be, okay, I don't want it to be too long, so I'm just gonna separate. So I'm gonna also get the APU because it's the one that comes after UAP, and then followed by the population underscore voting RC dot population. So now we have UAP, APU, and population. Now we need to get the district ID. They say the district ID is just basically the current row and column, the position of that district. So which is just RNC. So let me store that underscore voting RC dot district ID, right? Dot row. Okay, no, I'm not getting it from the user. I'm storing it. So dot row is equals to R and then underscore voting RC dot district ID dot column is equals to C. So now I have the district ID, row and column. And then the population must, the undecided value will be calculated based on the UAP and APU support. So I'm gonna basically undecided is, I think from this, what I can get from this, right? Undecided is basically, they didn't tell you, but you just have to think about it. Undecided is basically a percentage of people who were not able to vote, who were not, who didn't vote, who didn't know, they were undecided, they didn't know which party to vote for. So how do you find that value? So you add up these two percentages for the parties, and then you subtract that value from 100. The difference that you have is the percentage of people who were undecided. So I'm going to make it a bit simple and not make it too complicated. So I'm going to separate, I'm going to divide it. So it's a double, right? So it's a double. I'm going to call it undecided. And then it's going to be basically UAP. I'm going to say 100.0 minus, and then I need to put brackets so that it starts doing that first. It starts by adding, because if I don't do that, they have the same residence. The minus operator and the plus operator, they're of the same president. Let me see, both mass, addition, and separate. Okay, it is going to add first. But the problem with C++ or with language is that it only starts from left to right. So it's going to start from left and then look at plus, and then it's going to, okay, I think it might, but I don't want to take chances. This thing is, I don't want it to have unexpected data. So I'm gonna sum up the two districts percentages and then try to subtract from 100. And then once I've subtracted from 100, let me see. Yeah, absolute, there's the absolute function. So I'm gonna find the absolute value, because it might be, what is this, negative. So I'm just gonna find the absolute value of a double. What's the double value? It's undecided value. So make it positive, find the value. And then I'm also gonna make sure that it doesn't exceed 100. If it does, I'm gonna resize it, because they even said it. Remember that the support values must total to 100%. So the total must not exceed 100. So what I'm going to do is a simple if statement. If undecided is greater than 100, then remember that with if statements, while loops, and for loops, any expressions that you have, you can leave the curly braces, like you can leave them if you only going to have one line of code underneath that if statement or while loop. You can just have one line of code like this. So if it is greater than 100, then I change undecided back to 100 like this. But undecided is already there in my record structure. So let me just use that value. So underscore voting. I know it's going to be a bit long, but if you're paying attention, you'll understand that it's pretty much straightforward. So it's going to be dot undecided. Yeah. So I'm going to use that undecided variable like this. If it exceeds 100, put it back to 100. But since I'm generating this thing randomly, I didn't have to, but based on the question, I think there's the values that exceed 100, so you'd have to restrict. So we have everything. Yeah, that should be everything now. We're done reading from the file. Yeah, that's everything. So we've read from the file. We are done reading from the file. We've set the values the right way, and then we didn't forget to close the file. So we are done with that. So now we need to save the file to a binary file. So the way a binary file works, it interprets the data as strings or as a as an array. Okay, it actually interprets it as an array, not a string. It interprets it as an array of characters. So whatever data that we save into the binary file, we need to cast it to an array of characters. What is an array of characters? It's just char pointer. So we need to cast it to that. And we also need to specify the size of the thing that we're saving to the binary file. Could be just an integer, could be whatever that data or that variable that we're trying to store, we need to do that. Because if you check here, there it is, providing that our structs are not of a variable length, we can write them to disk by means of, so you can say this, and then you cast it to an array of characters, but remember you must take it by address so that it's faster. And then you also pass in the size of the record type. Let me see. Okay, this is, I think it's mainly for random access files, but also binary files. I think with binary files, you have to work with them like that. Okay, I want to see binary files. Let's see. Okay, there's the binary file, but they didn't go in depth. That's the problem. Characters, IO stream, truncate, binary. Formatting stream, object, open, that, exit, bu- 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 mm, must use IO manip. We don't want to use IO manipulation. In order to write to disk, we use the following functions. Yeah, that's how I remember it. Like binary files, you have to, it takes a char pointer when you want to write and char pointer when you want to read, if I'm not mistaken. But yeah, I think if I remember correctly, that's how you do it. So we want to save to the file. So OF stream object, right? So output, and then output dot close. Don't forget to close the file. And then I'm just going to say output dot open. Open what? This file with that file name. I want to open it in what is this? In output mode. So in out, I don't have to, but because it's already there, it's an output file stream object. I don't have to, but for the sake of demonstration, I'm gonna do that. And then append that or combine that with the binary to state that I'm opening it in binary mode so that I can output the values to a binary file. And then I can also say, let me not delete the data. Let me just append to it. So I'm gonna put app there at the end to say I'm appending to it. I don't want to delete the records that I already have. I'm just gonna add to it. And then I think when you now have to write the data, you just, and remember we're writing a record structure. we're writing record structures. So let's see how is there a structure for this thing, for the binary file? That will save the contents of the two-dimensional array to a binary file of records. So it saves it to a binary file. So we're going to have a binary file of records. So we are saving the records to the binary file. So I'm going to say unsigned and then R is less than underscore rows, R plus plus, and then I'm going to have for unsigned int C is equals to 0, C is less than underscore calls, C plus plus. And then now we can write to the file. And remember, we need to write. So output dot write like this. And then I'm going to cast the data, the record structure to, and it should be a const char pointer because it shouldn't change it. It should just store it. So it shouldn't modify it. So I'm gonna save it as a constant. The constant array of characters. What am I saving? The address of that district, voting district, and it's stored at each coordinate or each row column coordinate. And then I also specify the size of that record structure, which is underscore voting row column. So you see the size now becomes the size of function becomes quite useful because we've packaged this thing, remember, in terms of 1 byte. So it's gonna take 1 byte. Each record structure is gonna be of 1 byte each. So it's gonna do that. So that size function is gonna be very useful. So after doing this, you're basically done writing to the binary file. So open this and then open it in output mode, give it output privileges or writing privileges. You have the right to write to this file. And then you're writing it in what mode? In binary mode. So in terms of binary. And then what do you want to do else? I want to append to it. I don't want to delete information that was already there. I just want to append to it. I feel like that's more useful instead of having to delete, because what if, remember that you're saving this to binary. So if you keep saving changes, you obviously want to save new pieces of data. You don't want to override what was already there. So this is how you'd save to the binary file. Yeah, this is always the syntax. You take an array of characters, which is the data, and its size in terms of bytes, of which we packaged it into 1 byte each. So even if you wanted to write an integer to a binary file, so let's say you wanted to write int value -29, you wanted to write this value to the binary, you write it like this, dot write, right? And then you say interpret, then make it a const char pointer because everything isn't interpreted as an array of characters. So you need to cast it to an array of characters. And the const is important because you don't want it to be you don't want to change it in the process of adding it there. So take the address of what value and its size in bytes, size of value. There we go. That's how you're going to write to the file. But that's all we had to do there. We are done. I think we are basically done with this class now. It is actually now complete. Yeah, I think it is complete now. We can sort of step away from it and work with polymorphism and what. So let's do that. Before we do that, let's try to fix these issues now. Incomplete class. Why is it doing that? I know it is incomplete because it has this pure virtual function. Okay, since it has the pure virtual function, I honestly don't need the voting analyzer's CPP file. I think that could be the issue. I don't know, but let's let's try to fix that. Let me see. Binary files, where's the information about this? Uh, because we could need data that's protected. Yeah, that's one thing that I want to check. Yeah. Okay. Let's just delete it. I don't need voting analyzer. Then now we need to fix other errors. Let's see. Generating. Okay. Let's start with this one. Use of incomplete type. Well, it's not incomplete as such. Let me see. Well, I did import it. It's not incomplete. Why is it complaining? Expected class name. You see, that's the thing. It's gonna complain that it's incomplete, and then it's gonna complain that it wasn't. It's always gonna complain. I don't know why it likes doing that. Let me see. Voting. You see, that's the thing. Inside voting analyzer, I did do the forward declaration for voting grid, and I included the header file for voting grid. So technically, I don't need voting grid here. I only need voting analyzer for that. If it's still giving me errors, then maybe I should try doing forward declaration only for voting analyzer. But I don't know why why does it have to be such a pain? Because all imports are done, and then now it complains about something else. I'm using an incomplete type. Why would you complain that it doesn't know that you don't know about this type, and yet it's still this thing? Voting grid is inside voting analyzer. So I don't want to have cyclic dependencies and including things more than once, because that's the thing about data file. As you can see, if it is not defined, it avoids you some of the features of preprocessor directives is to prevent you from redeclaring something that already exists. So me having to include and include and include, yeah, that becomes a problem. So let me see. What if I write it here? Class voting analyzer, incomplete class. It's not an incomplete though. Mm, let's see. I do include it though. Voting analyzer, there it is. I mean, it does have a virtual function, but I am specifying that it's inheriting from the class. So it should be working fine. Voting grid, class name. And this error occurs quite a lot. Okay, so let me do something like this. Let me do this. Let me try to return an empty string for all these functions and see what happens now. return this, right? And predicted outcome, return empty string. Yeah, so now it's not going to complain about the returns. Now it's going to complain about the classes and whatnot. Does not name a type. That's the problem. If I do the forward declaration, it's also going to moan at me. I don't know what it wants now. Predicted outcome, voting analyzer. Let me think. Voting grid. Wait, is the voting analyzer class complaining? No, it's not. Does not name a type. I don't want to repeat. There's includes whatever. I want to repeat them. So let's see. It's still saying voting analyzer doesn't name a type. But, okay, seems like now it's only complaining about the voting analyzer. So let's do the quad declaration. And now it's saying invalid use. This thing doesn't know what it wants. Okay, let me cut this recording short. Let me just go continue the next part. I'm not sure why it's doing that. It should be working. It's just small minor issues. So see you in the next recording.